Hello guys, welcome back to learning microcontrollers. In this video, I'm going to show you how you can make an obstacle detection system using IR transmitter and IR receiver sensor by using a PIC16F877A microcontroller. So let's get started. So first of all, this is our PIC16F877A microcontroller DIP version having 40 pins. This is an IR receiver LED. You can easily buy it from any electronic market. It's very cheap and it is also found in televisions. This is our IR transmitter LED. It will transmit the IR ray which we will use to detect the obstacle, and we will need a 10 kilo ohm resistor for IR receiver LED to interface it with the PIC. We will need a 330 ohm resistor for the IR transmitter LED to interface it with the PIC. Let me show you how to do the connections. First of all, you name the shorter pin of the IR receiver LED as in and larger pin as ground. But you can shuffle these two pins as you like, doesn't matter. And first of all, you connect in pin directly with the VCC, that is 5 volt pin of the PIC16F877A. Then you connect or you take your ADC value from the second pin, that is a ground pin, and you can use any available ADC pin on the PIC. I am using pin A0, that is pin number 2. Now from the same pin you take a wire to one end of the 10k resistor. From the other 10k resistor you send it to the ground. This is our grounding resistor. In this way our IR receiver LED is connected. Now let's connect the transmitter one. Transmitter is just like a normal LED. You name one larger pin as the power pin, shorter pin as the ground pin. You connect ground pin directly with the common ground, and you connect 5 volt pin to the one end of the 330 ohm resistor. From the other end, it goes to the 5 volt supply. It's just like a normal LED. That's how you connect a normal LED. Now for the purpose of calibration and also to display the output, I am going to use this 16:1 LCD. This is a simple LCD with only one line display, and it has no backlight. It's very easily available in the market and it's very cheap. But to interface this, we will need a 3-pin variable resistor to adjust the contrast. You can use a 10 kilo ohm resistor. This resistor has 3 pins as label on it, 1, 2 and 3. And this LCD has 16 pins. If you hold it like this from left to right, it's 1 to 16. Now let me show you how to do the connections. You connect pin number 1 and 5 of the LCD with a common ground. You connect 1 and 5, short them and then ground them with a common ground. Then you connect the same ground to the pin number 1 of the potentiometer, that is variable resistor as well. Then pin number 2 of the LCD goes to pin number 3 of the potentiometer. From there you send it to the common 5 volt supply. In this way you give 5 volt to the LCD and also to the potentiometer. Now pin number 3 of the LCD is the contrast adjustment pin. You will send it to the pin number 2 of the variable resistor. Now we do the connections for data lines and enable an RS of the LCD. Pin number 4 is the RS pin. You connect it to any available digital input output pin of the PIC16F877A microcontroller. I am using pin number C0, that is pin number 15. For EN pin, I am using C1, enable pin. Then you use a pin number 11, that is data pin 4. You can use any digital input output pin. I am using C2 for this. For data pin 5, C3. For data pin 6, D0. And for data pin 7, D1. Rest of these pins 7, 8, 9, 10, 15, 16 will go empty, because 7, 8, 9, 10 are used in 8-bit mode while we are using 4-bit. 15 and 16 are for backlight, and this LCD has no backlight. In this way our total connections for this project are complete. Now let me show you how it will work. This is our PIC16F877A. This is our transmitter LED, and this is our receiver LED, and this is the LCD on which our output will be displayed, and also we will use it for the purpose of calibration as well. And this is the obstacle we will be using. Any obstacle that will be detected by this system. This is an IR ray. As I had shown you, this LED is directly connected with the PIC, that it is getting the power. It's totally on as soon as the project is on. It will be sending IR rays directly, and this receiver LED is connected to our ADC pin. It will keep on sending ADC values to the PIC, and PIC will keep on displaying them on the screen. As you can see, as long there is no obstacle in the path, there will be some random value on the screen like 12 or 13 or 0, or depending upon the calibration we will do, it will be giving us some value. But when an obstacle is in the path, IR ray will hit the obstacle and IR receiver LED will receive the reflected IR ray, and it will send the ADC value to the PIC, and PIC will display it on the screen like there will be a change in the value like 400. It means that whenever an obstacle is at this distance, it displays this ADC value. So I move the obstacle a bit closer. Again IR ray will hit the target. Again IR receiver LED will receive the data, and it will send the value to the PIC, and PIC will do the ADC conversion and will display it on the screen. And there will be a different value when we change the position. Now we take this value, suppose it's 350, depending upon what we will get on the screen when we will go to the hardware. I take this as our threshold, that whenever there is 350, it means the obstacle is at a considerable distance to be detected as a danger. So then we will calibrate our PIC in such a way that whenever an obstacle is detected at this position, PIC will display obstacle detected. And when it's removed, it will display clear, that it's clear, you are clear to go. Again, obstacle detected, again clear. So guys, in this way, our project is gonna work. So let's get to the MikroC for PIC programming. So guys, this is our MikroC for PIC. Let me zoom it in. Go to File, New Project. Click on Next. Write the name of the project, IR Obstacle Detection. It's the name I am giving this project, LM Learning Microcontroller. I am using a PIC16F877A microcontroller, and the crystal I am using is 20 megahertz. Select this, click on Next, 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 and finish. First of all, we initialize our LCD. For that, you go here, there is the library manager, click on it. There you have LCD, expand it. Go to LCD INIT, double click on it. Here you will have this screen. Here in the screen, you can see there is an example of the initialization command of an LCD. You simply copy it, paste it above the one-time loop here. Now here RS is defined as B4, while we had defined it as C0 as shown in the presentation. For enable, we are using C1. D1 for D7, D0 for D6, C3 for D5, and C2 for D4. So these are the pins we defined in the presentation. D7 for D1, D6 for data pin 6 we are using D0, for data pin 5 C3, for data pin 4 C2. If you use any other available digital input output pin, then you only have to change these parameters, rest will remain the same. Now do the same for the directions. For RS we are using C0, enable C1, data pin 7 we are using D1, for data pin 6 D0, for D5 C3, for data pin 4 we are using C2. So in this way our 4-bit mode is initialized. Now let's get to the one-time loop. Here you write this command LCD INIT. This will initialize our LCD INIT and the semicolon. Give some initialization delay. 500, 0.5 millisecond will do enough. Okay, now the LCD is initialized. Now the next thing is we are using an ADC pins. For that purpose, initialize the ADC module of the PIC16F877A. This command initialize all the ADC pins of the PIC16F877A. Now you can use any ADC pin as you like. Now we go to forever loop. We have our LCD initialized. We have ADC pins initialized. Now all we need is to go to forever loop. Write this, forever loop starts here, ends here. First of all, we need to read value from the IR receiver LED. For that purpose, you go to library manager, click on ADC. Here you have ADC read, double click, copy this command, place it here. So for this we will need you can say a variable which will store the value, read value, int integer read one. This is the variable which will store the value read from the IR LED. So here read one will read a value from which channel, that is channel number 0. We are using pin A0. So we define the channel as A0. If you use any other channel, you only have to do is that you have to change this 0 to 1, 2, 3 depending upon the whichever channel you are using. For A0 it's 0. For A1 it's 1. So now ADC value will be read. Now as you know, LCD cannot display integers directly. We need to convert this integer to a string. For this we will need a string variable. Write char read 2, it should be a 5, like it can store 6 digits. That's enough to store the value read. So we use a command int2 string str read 2 read 1 to read 2. In this way, the value stored in read 1 will be converted to a string read 2. Give some initialization delay. 50 will do fine. Now we display it on the LCD. To display it on the LCD, you can first of all we remove the cursor. We do not need the cursor in this project. Go to LCD CMD. This is a command. Here you have this command LCD CMD clear. You copy it. You place it below the where you had initialized LCD. Here, give some initialization delay. 100 millisecond will do fine. Now again you go back to the library manager LCD CMD. In the table below there is a table given. This table available LCD commands. You have a command called turn off cursor. You copy it. We do not need the cursor, so we simply remove it and you place it here. In this way our cursor is removed now. Now to display the data on the screen, you go to library manager, click on LCD out command. Here you have this example, you copy it, you place it right below it here. Now LCD out what? It is the first row, first column, display the value received, that is read 2. That's why we did the conversion to string. We cannot display read 1 directly on the screen. For that we need a string. Read 1 is converted to a string here. So read 2 will be displayed on the screen. Give some delay for how long the value should be kept on displaying. For 0.5 second is enough. Now after displaying the value, LCD should clear itself for new values. For that purpose, you go to library manager, click on LCD CMD. Here you have LCD CMD, this command. This means LCD command LCD clear. It will clear the screen for new values. You give some initialization delay. 50 will do fine. In this way, our first code, that is for the purpose of calibration, is complete. We will use this code to get our random values, a threshold value depending upon which our obstacle will be detected at a required distance. So we build it. Now let me introduce you to the hardware. So this is our PIC16F877A microcontroller. As you can see, this is a PIC 3.5. I have a video whose link will be shared in the description, how you can set up this board. And this is, as you can see, are our sensors. That is, left one is the IR receiver LED. Right one, this is the IR receiver LED on the right. Left one is the IR transmitter LED. And this is our LCD, as you can see. And this is IR receiver and transmitter. So guys, this is our basic project, and wirings are as shown in the presentation. So let me, okay guys, now you can see both. This is our IR transmitter and this is our IR receiver, and this is the LCD on which we will get our values. And this is my obstacle. I will be using this piece of paper as an obstacle. I will place the obstacle in front once I run the code. Let me first burn the code. So for this purpose, we are going to use this code is only for the purpose of calibration. Once we are done with the calibration, we will write our main code. So you turn on your PIC 3 programmer software. Click on check communication. The PIC 3 found. Now go select your microcontroller. I'm using PIC16F877A. Here we go. Now import the file you just built. IR obstacle detection, click on write. Okay guys, as you can see, the program is being written. Let it write the program. Let's see what happens. Okay, our program is written. Now we give 5 words from the PIC 3. Okay, now program is running. As you can see, there is no obstacle in front. So we are getting a value like 19, 18. That's what I told you, that you will get a random value like 12, 18, 16, as you can see in this LCD. This is the value we are getting right now. because there is no obstacle in front. But when I bring an obstacle in front, then see what is the change that comes. Now I bring an obstacle, see there is an obstacle, okay, the values changed. 88, I remove the obstacle, 18. I again place the obstacle, 85, 112, 114, I move it further, see it's away, values drop. I go further, it drops further, I go further, drops further. When I bring it close enough, see now it's near, values go very high. When I bring it nearly its head, it's like 978, 977. I take it back, 128, 130. So for the detection obstacle, usually when you are making a robot car or something like that, or any other application like object counter, etc., this is a sufficient distance. So I take this like when the value is at 130, an obstacle is being detected. This is a sufficient distance for an obstacle to be detected. So we go back to our MikroC for PIC. Now guys, we have our threshold, that is 130. Now after this read command, you write if read 1 is greater than 130, it means an obstacle has been detected. Like if we go near, the value increase. So what's gonna happen is that LCD is gonna display when it's greater than read 1 is greater than 130, it means an obstacle is detected, and LCD will show obstacle on the first row. I have a tutorial on how to use this LCD as well. I will share the link in the description. See, this LCD can display only 8 digits on the first row, and next 8 will go on the second row. So detected will be on the second row. So obstacle detected, displayed for 100 milliseconds if it's above 130. Else in any other case it will display clear. So what it displays in any other case, it displays clear. And for the second row, since there is some digits there, we will need to do something about it, else it will display detected on the second row. We make it all 8 digit go 1 2 3 4 5 6 7 8. Clear? Okay, now our calibration is done. Since we do not need to display our values on the screen, we do not need to convert it to a string now. We do not need to display the value on the screen. All we need is only LCD to display either detected or clear. So now let's burn this program, change our program. Go to PIC3, click on write. Program is already selected. Oh, the program is being changed. Let's see what happens. Let it burn. Okay, our new program is written. See, it's displaying clear. There is nothing in front. So this is what we intended. Now what I do is that I bring an obstacle in front and see what happens. So this is obstacle. I go far. See, it's showing clear. It's too far. I bring it near. So see, this was our threshold. It says obstacle detected. Now again I bring it far, clear. I bring it near, obstacle detected. Now you can use this threshold to do any programming. Like in the loop, you can write the motor to turn on, motor to reverse. If you are making a car, if you are detecting an object is detected. And if I go further, see, it shows clear. I bring near, it shows optical detected. So guys, as you can see, our program is working as intended. So thank you for your time. I hope you guys learned something from this video. See, as soon I go, you can even change this threshold. You can make it here or here, depending upon how much distance you want the obstacle to be detected at. But I had set this threshold. So if you go anywhere near, see, oh sorry, it says detected anywhere near. But as soon as you cross a threshold, it says clear. That obstacle is far away. So guys, I hope you guys learned something from this video. Thank you very much for your time and have a nice day.